Hello students, welcome to my class. In my last lecture, I was discussing about potassium dichromate. Today I will continue with the same topic and will provide few more information. Clear my friends? So let's start. That is, I have discussed that is last topic Cr2O7 2 minus can be converted to CrO4 2 minus chromate ion. Dichromate can be converted to chromate and chromate can be converted, that is CrO4 2 minus converted to dichromate. They are in a equilibrium at pH is equal to 4. Clear? If alkaline solution, that is there is a existence of Cr chromate ion. If there is a acidic solution, there is a existence of Cr2O7. That is, if pH decreases, then we get Cr2O7. If pH increases, we get CrO4 2 minus ion. This is, my friend, orange in color, yes, and this one is yellow in color. Clear to you? This was the test. Now the next one, few properties. As we know, K2Cr2O7 act as a strong oxidizing agent. Yes, oxidizing agent. Definitely it act as a oxidizing agent. Why it act as a oxidizing agent? I have discussed in here chromium is in higher oxidation state. By reaction you can also prove it when it is treated with in acidic, that is it form K2SO4 Cr2SO4 whole thrice plus H2O, and there is a release of nascent oxygen, and this release of nascent oxygen proves that it acts as a strong oxidizing agent, my friend. Clear to you? This is the case, it acts as a strong oxidizing agent. Next one, it is less soluble or moderate soluble in water, in cold water, my friend. But solubility increases if the temperature increases, that is, but it is highly soluble, in hot water, my friend. Again I am repeating, it is less soluble in cold water but highly soluble in hot water. It acts as a strong oxidizing agent. Now how it acts as a strong oxidizing agent, listen carefully. When K2Cr2O7 is treated with Ki, acidified Ki solution, then it converts Ki into I2, my friend. What I am telling, when K2Cr2O7 is treated with Ki solution, then it converts Ki into I2, that is the oxidation state of I that is -1 converted to 0, and K2Cr2O7 converted chromium is in +3 oxidation state. Now if the oxidation state increases, that means to say it is acting as a oxidizing agent, my friend. Clear to you? Now the next one is, when K2Cr2O7 acidified is treated with FeSO4 ferrous, that is Fe is in +2 oxidation state, it convert it into Fe3 plus ion, that is Fe2SO4 whole thrice, my friend. That is ferrous sulfate into ferric sulfate. It also proves that it acts as a strong oxidizing nature. It has a oxidizing nature in all medium, in acidic, in basic, as well as in neutral medium also, my friend. In all medium it acts as a strong oxidizing agent. Clear to you? Now again, when K2Cr2O7 acidified is treated with H2S, it convert H2S into S. Look at here, sulfur is in -2 oxidation state, converted to 0. That is, there is an increment in the oxidation state. If there is an increment in the oxidation state, it proves that K2Cr2O7 act as a strong what? Strong oxidizing agent. Now if K2Cr2O7 is treated with Na2SO3, it convert Na2SO3 into Na2SO4. Here Na2SO3 sulfur is in +4 oxidation state. Clear to you? But in Na2SO4 it is in +6 oxidation state. There is an increment in the oxidation state. Again, it proves that it acts as a strong oxidizing agent. Clear, my friend? Now again, when it is treated with K2Cr2 treated with Sn2 plus ion, it convert Sn2 plus ion into Sn4 plus ion. It also proves there is an increase, it acts as a strong oxidizing agent. Lots of reactions are there. Lots of reactions are there. Now when K2Cr2O7 is treated with H2O2, acidified K2Cr2O7 is treated with H2O2, then there is a disappearance. This is a VVI reaction. There is a disappearance of the orange color take place, and we find deep blue color. What I am telling, we find deep blue color solution. What is the reason behind it? Due to the formation of CrO5, my friend. Again I am repeating, when K2Cr2O7 is treated with hydrogen peroxide, the orange color disappears and there is a appearance of deep blue color. Why there is a appearance of deep blue color? Due to the formation of CrO5. The blue color fades away after some time due to the conversion of CrO5 into Cr3+. Here chromium is in +6 oxidation state, my friend, not +10. Why not +10? Because chromium has maximum oxidation state +6. As I discussed in redox reaction, if there is the oxidation state increases by using the normal rule, that means to say, if I put here chromium X -2 into 5 equal to 0, X -10 equal to 0, X is equal to +10. General trend says that chromium should have oxidation state +10, which is not possible because chromium has outermost electronic configuration 3d5 4s1. 3d5 4s1. What does it mean? It means it has only 6 electron in its outermost shell. If it has only 6 electron in its outermost shell, the maximum state oxidation state should be +6. So how to modify this? That means to say there are few oxygen which is in a peroxy linkage, my friend. That is definitely in CrO5 there are some peroxy linkage. Why peroxy linkage? Because the oxidation state exceed to +6, which is not possible. That means to say there are few oxygen which have oxidation state -1, and we know oxygen as oxidation state -1 only in case of peroxy linkage. So definitely we can guess here that CrO5 has peroxy linkage, my friend, and CrO4 has definitely that, my friend, butterfly structure. Again I am repeating, CrO4 has butterfly structure, my friend. Clear to you? This is the case, and the structure is like this, my friend. Chromium, this one, wait, like this, chromium, oxygen, then double bond, oxygen, peroxy linkage, wait for a moment, O, 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 then 1, 2, 3, 4, this is the peroxy linkage structure. Clear to you? This is the, my friend, peroxy linkage. Peroxy linkage. Clear? This is the peroxy linkage. Clear? And in peroxy linkage, oxygen has oxidation state -1, -1, -1 and -1. Now modified them, find it out. You will find right here oxygen X plus -2 plus 4 into -1 is equal to 0. X minus 2 minus 4 is equal to 0. X is equal to plus 6. Now look at, we get the value of X is equal to plus 6 oxidation. This proves that in CrO5 there is a peroxy linkage and the structure is butterfly structure. Again I am repeating, this is a VVI and there is a question from previous year board examination. Clear to you? Any doubt? No sir, no doubt. Now next one, I am moving here, my friend. Check it out what I am telling. So we can easily say Cr2O7 act as a strong oxidizing agent. Now there is a next one. The next one is, my friend, that is chromyl chloride test. Chromyl chloride test. What is chromyl chloride test here? Listen carefully. This is generally used to detect the Cl minus ion in qualitative or quantitative analysis. Clear to you? What will happen when K2Cr2O7 is treated with concentrated H2SO4 and soluble salt NaCl? Then what will happen? There is a formation of chromyl CrO2Cl2. There is a formation of chromyl chloride take place. Chromyl chloride take place, and this is yellow in color. Clear to you? No, sorry, pardon. This is not yellow in color. Pardon, my friend. It is when treated with NaOH. Then it will give a yellow color, Na2CrO4. This is the yellow color. Pardon, my friend. This is the yellow color. But when K2Cr2O7, this is orange color, when treated with concentrated H2SO4 and the salt solution NaCl, there is a orange reddish brown vapor. You can say only orange, in many book it is given orange reddish brown vapor, or simply you can say reddish brown vapor. There is a reddish brown vapor formation take place, and this reddish brown vapor is due to the formation of chromyl chloride. When chromyl chloride further treated with a strong alkali, there is a appearance of yellow color take place. That is, the reddish brown vapor disappears and yellow color appear due to the formation of sodium chromate, Na2CrO4. This is used for the detection of Cl minus ion, my friend, and this is the powerful important chromyl chloride test, my friend. Am I right? Yes sir. This is again a VVI things. If you have doubt, you can easily approach to me. Again I am repeating, the byproduct here is KHSO4 NaHSO4, but here we have to check out only the I am discussing about only about the chromyl chloride, my friend. because the color changes. Orange converted to reddish brown vapor, my friend, and reddish brown vapor, the reddish vapor proves that there is a formation of new compound, and this is chromyl chloride, which further treatment with NaOH, that is alkali, there is a appearance of yellow color take place, that is CrO4, Na2CrO4, that is CrO4 2 minus ion. Am I right? Yes sir, you are absolutely right. Now the next one is what will happen when the decomposition of Cr2O7 take place. When we provide heat, then what will happen in this case? When we provide heat, that Cr2O7, K2Cr2O7 converted to K2CrO4 plus Cr2O3 gas. This is the two important component. First convert K2CrO4 and Cr2O3 gas, oxide of chromium. This is potassium chromate, and this one is, my friend, oxide of chromium. Am I right? Yes sir. These are the few properties related to, my friend, potassium dichromate, and definitely it will help you a lot, my friend. I am giving you few seconds to note it down. I think you have noted it down. This is one of the most important topic related to this chapter, and definitely, my friend, it will help you a lot. I have discussed each and every important things related to K2Cr2O7. Now if anyone asks you what is the equivalent weight of K2Cr2O7 in acidic medium and what is the structure of chromate ion, is very simple. Now tell me. This is your turn. Now friend, tell me how to find the equivalent weight. Okay, the equivalent weight of K2Cr2O7. Okay, that means to say we know it acts as a strong oxidizing agent. Yes sir, definitely. In acidic medium I am talking about, that is Cr2O7 2 minus, acidic medium converts into Cr3 plus. Now 2 balance 2. Now ion electron method and oxidation number method, you know how to balance the reaction. How many oxygen is here? 7. Add 7 water, 7 H2O. Now 7 to 14 H plus. Now charge balance. What is 14 to 12, 6, that is 6 electron. Yes sir. So the equivalent weight of Cr2O7 2 minus is molecular weight, molar weight of K2Cr2O7 upon number of electron lost or gained. How many electron lost or gained? That is 6. That is molecular weight of K2Cr2O7 upon 6. This is the equivalent weight of K2Cr2O7. Now the next one is, what is the structure of chromate ion? CrO4 2 minus. It's very simple. Chromate ion structure is chromium, oxygen here, one oxygen and another oxygen, minus sign. It looks like that is a tetrahedral structure. This is chromate ion, my friend. As I told you earlier, this is not a double bond, my friend. This is the coordinate bond. Clear? So we can write here chromium, oxygen, 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 oxygen to the power 2 minus. This is the structure. Actually, again I am repeating, this is not a double bond, this is a coordinate bond. This is the structure of CrO4 2 minus. I have discussed the structure of Cr2O7. Clear? Remember this? Yes sir, we do. Add both this chromium, add one with this, and we get the structure. So I have discussed the important explanation, important things related to K2Cr2O7. Now I am discuss the next one, next important powerful oxidizing agent, my friend. potassium permanganate. So let's start the topic potassium permanganate. And what is potassium permanganate? I will discuss it later. But first of all, I will discuss about the powerful oxidizing nature, my friend. This is the case of potassium permanganate. So the topic here, the next one is KMNO4, my friend. This act as a strong oxidizing agent. Strong oxidizing agent. Clear to you? In all medium, that is basic medium also, acidic medium also, and in neutral medium also. Clear to you? Acidic, basic and neutral medium. As we know, it will dissociate like this, K plus MnO4 minus. Clear to you? If anyone asks you to draw the structure of permanganate ion, it's very simple. That is MnO minus double, and this one is the case. Clear, my friend? But as I told you earlier, this one is not a double bond, this one is a coordinate bond. According to your NCERT book, they arrange here the double bond, but here only the partial donation of lone pair of electron take place via coordinate bond formation. This is the structure of MnO4 minus ion. Now, if anyone asks you what is the equivalent weight of KMnO4 in acidic medium, in neutral medium and in basic medium, it's very simple. That is what that is, my friend. I am taking the one example in acidic medium. Clear to you? Look at what is happen here. That is acidic medium, that is the presence of H plus H2SO4. In basic medium, that is KOH, NaOH, that is the base. Now in acidic medium, what is given here? MnO4 minus ion H plus, that is converted to Mn2 plus ion. Yes sir. Now balance, there is 4 oxygen, put here 4 H2O. So definitely we will put here 8. Clear? Now charge balance 8, 7, that is 2, that is we include here, that is 5 electron here. If you have any doubt, you can also use the oxidation number method. Here Mn is in plus 7 oxidation state, converted to 2. So total decrement in the oxidation state is 5. So equivalent weight is equal to molecular weight upon N. What is N, my friend? Number of electron gain or lost or change in oxidation state, or decrease in oxidation state or increase in oxidation state. What is the molar weight of KMnO4? It is around 158, what I think, and N is equal to, my friend, 5. You can find the equivalent molecular weight easily, and N is equal to 5 here, change in oxidation state 5. So the equivalent weight of MnO4, that is KMnO4 in acidic medium, is 158 upon 5. Now if anyone asks you what is the case of neutral medium, similar happens. That is in neutral medium, number of electron lost or gain is 3. So the equivalent weight in neutral medium, that is, my friend, molecular weight upon 3, that is 158 upon 3. This is the case. That is, the equivalent weight is always changing, it is not fixed, but molecular weight is always fixed. Now the simple one is basic medium. Now we know base may be strong, may be weak. If there is a strong basic medium, listen carefully, if there is a strong basic medium, then what will happen? That is, equivalent weight is equal to molar weight upon 1. That is the value of N, that is only 1. That is change in oxidation state only 1. That is, we can write here 158 upon 1. Clear, my friend? But if there is a presence of, weak basic medium, again I am repeating, if there is a presence of weak basic medium. Then what will happen in this case? The equivalent weight is equal to, that is the molar weight upon 3 number of electron lost or gained here, that is 3, and we say that is here if it act as a oxidizing agent always gain not lost, and change in oxidation state here is 3 on always there is a decrement in oxidation state not increment, because KMnO4 is what? Oxidizing agent. So the answer is 158 upon 3, my friend. These are the cases. These are the cases related to the KMnO4, and these are very helpful in competitive examination as well as in board examination. So we have two things, two important compound in this chapter, that is K2 Cr2O7 and my friend KMnO4, and these all act as, again I am repeating, now I am not going to add the new topic because now I have lack of time, and definitely I will introduce the next topic in my next lecture, because now I have to discuss the properties related to KMnO4 and the preparation related to KMnO4. Now few things that is important. Then they act as a, generally they ask, they act as a strong oxidizing agent. Listen carefully again, they have a, why they act as a strong oxidizing agent? They act as a oxidizing agent because, why? Because they have, in this molecule the compound is in higher oxidation. In this molecule the central atom, that is the transition metal atom, is in higher oxidation state. Here the +6 oxidation state, and look at +7 oxidation state. It cannot further increase in oxidation state. Only the decrement in the oxidation state take place. Due to this reason, my friend, they act as strong oxidizing agent. Second one, when treated, they have a, when in a reaction, they have a tendency to release, my friend, nascent oxygen, and due to this reason they have a tendency to release nascent oxygen, they act as a strong oxidizing agent. So simple explanation related to this. And generally in school examination, in competitive examination they ask the property, but in school examination they ask, that is board examination, why they act as a strong oxidizing agent. This is the reason, my friend. Nascent oxygen tendency as well as in higher oxidation state. So my friend, these are the few topics related to this chapter. In my next chapter, pardon my friend, in my next class I will discuss about the properties related to KMnO4 and the preparation, and will introduce the F block element. Clear, my friend? Till then, bye bye. Thank you so much.